So here we have another advanced physics problem. So from electromagnetic theory, let me just read the problem for you. A rectangular loop of dimensions L and W moves with a constant speed V through a region containing a uniform magnetic field B directed into the paper, okay, and extending a distance 4W. So this is 0, this is 4W. You can see the dimension L. Okay, this is the region of the magnetic field. Which of the following figures correctly represents the variation of EMF with position x of the front end of the loop? Front end of the loop is this end. Okay. So look, this problem is quite good problem. So what things are happening as this loop keeps on moving from this position into the magnetic field and it is coming out of the magnetic field. So we have to consider three different cases. The first case is here when it is outside the magnetic field, when it is entering into the magnetic field. This is region 2 when it is completely inside the magnetic field, and third case when it is leaving the magnetic field. The status before entering the magnetic field and after leaving the magnetic field is same. This one we know. So I am showing you these three situations. In the first situation, it is entering into the magnetic field. Second situation of case 2, it is completely inside the magnetic field. And third case, it is leaving the magnetic field. So let's consider the first case. So case 1, you can see this is the situation at x is equals to 0. What is the magnetic flux? No, the formula of magnetic flux is electric field dot the area EA. Okay. So this is, sorry, here E is B, actually BA. So this is equals to 0. Since no flux is passing through it, because x is equals to 0 means this front end, we are talking about the front end. The front end is here. So it has not entered into the magnetic field regime, because magnetic field is extending only in this regime between 0 to 4W. Okay. And when the front end is at this point, means it is like this. This is the front end and this is x equals to 0. So at this point there is no flux. Since no flux is there, now when we are talking about at x is equals to dx, so it has entered dx amount, then what will be the magnetic flux? Here now it is in this portion, is in this magnetic field. So B into A area, this is dx and the length is L. So L into dx, this is the flux. So what is the change in flux? Change in flux will be manifested as the EMF. E is equals to minus df by del F by del T. This is your induced EMF. That will give rise to the current. A current will flow through the circuit because of this change in flux. So this is equals to minus BL into dx by dt. Dx by dt is the velocity given to you v. So this is minus BL into v. Okay. So the induced EMF is minus BL into v. Now this is entering, so the flux will keep on changing. So you can see it will keep on maintaining this level of minus BLB. I hope you can see it. Okay. This is inside. This is when it is just entering into the magnetic field. Case 1. Okay. Now this flux will keep on changing till how much? Till it is completely inside the magnetic field. Okay. Now so you can just write a line here that the change in flux persists till x is equals to 4, x is equals to w, let's say. Yes, here x is the, you can say, position coordinate of the front end of the loop which you have been asked. So this is case 1. In case 2, what we have, मेरा handwriting दिन ब दिन इतना कठिन हो रहा है guys. This is case 1, this is case 2. In case 2, you see it is completely inside, so there is no change in flux. So when in between x is equals to 0, x equals to w, to x is equals to 4w. Okay, here there is no change in flux. There is no change in flux. If there is no change in flux, what will be the induced EMF? Induced EMF will be 0. So that's why between W to 4W, this induced EMF is 0. Again, when we consider case 3, case 3 is the case when it is living. So it will be similar to case 1, but as it is living, so the scenario will be just opposite. Similar but opposite. So that is why in case 3, the magnitude of EMF will remain same, BLB, but the direction will change. So instead of minus, it will be plus BLB. And as you can see, it is plus BLB. And look, it will take some time to leave this magnetic field. So it will fix at plus BLB for some width of W. Okay. So this is best represented in figure C. So option C is the correct option. So guys, before ending the video, let me just tell you a few things. Okay, so इसका answer है C. Before ending the video, let me just tell you that you can follow me on Unacademy Plus. You can visit my profile. This is our referral code Physics Hub. You can have a look at my courses by visiting this URL. You can see the URL /Physics Hub, and you can get all these detailed course: mathematical physics, classical mechanics, electromagnetic theory, and many more. A lot of benefits are there of taking an Unacademy Plus subscription. It includes daily live classes, part length and full length tests, assignments, the real solution, proper structured codes, and many more benefits. This kind of fee structures are available. You can go for 3 months, 6 months, 12 months, or 24-month subscription plans. And if you apply our referral code Physics Hub, PHYSICXHUB, you will get the maximum benefits. Okay, so take the Unacademy Plus subscription today and put your feet on step ahead towards reaching your goal. If you're new to the channel, subscribe to the channel and don't forget to press the bell icon. All the necessary links, Telegram group links, WhatsApp group links, everything is given in the description section. You can just check them out. And okay, this is for the video. Thank you very much. See you in the next video.